As you guys said, I'm Dave McKenna, and just as kind of a kind of set the record straight here, just in case everybody's wondering, I am not a famous jazz pianist. That is not me. Although I envy his hairline. Number two, I did not write the screenplay for a very disturbing movie called American History X. That's not me. Who I am, like I said, I have strange hobbies where I do strongman stunts. I wrote a book called The Art of Scrum that was released back in 2016, 96. Yeah, there you go. There's a copy of it. I do blog a lot. I have a website called The Agile Sumo. I do work with kids every chance I get. I also get up in front of people and speak every time somebody will have me because I love nothing more than a captive audience. I also play a pretty mean bass guitar as one of my hobbies as well. So one of the things I love to do, speaking of an Agile perspective, is I love to go to these open mic nights, just jump on stage with people I never played with before and try to figure out how to play a song. To me, that's fun. I don't know, a little twisted, but that's kind of the way it goes. And I'll just let you guys know that I have a very, very bad habit of speaking fast. Tell you a little story. Back when I was in the Air Force, I spent 3 years in Germany, and there's a bit of serendipity. I had taken German in high school, so I got pretty good at speaking German. And the Germans told me I spoke German too fast, so I'm a lost cause. So if I start speaking another language, feel free to just say, Dave, can you slow down? You're not going to hurt my feelings. All right. All right. So let's get into what we're doing here. So I should probably start at the beginning. What is a mainframe? A lot of times when I say mainframe to people, they think of that Whopper computer from the movie War Games. Yes, I'm dating myself. Or a big box with idiot lights flashing on it, right? And that's not really what a mainframe is. A mainframe is still, in the 21st century, the workhorse of the corporate data center. The mainframe lives in a transaction-based world. It can, like it says here, it can handle terabytes of data without breaking a sweat. If you kind of look at it, pretty much, if you think about Fortune 1000 companies, really specifically banks, they are based on mainframes, banks, insurance companies, things of that nature. That's where it is. It has a greater degree of security. It's basically the most secure platform on the planet for two reasons. Number one, security is built into every level of the mainframe structure. The processor, the operating system, the memory, the storage, all that stuff. And everything is, I often joke around and say, if I can give a hacker carte blanche access to a mainframe, he's not going to know what to do because you can't write it's hard to write a virus in COBOL. But there is security built in the entire platform as well. And the Z in IBM System Z stands for zero downtime. It's designed for 99.999% application availability. The whole platform is built with redundancy and zero downtime in mind. That's about 5 minutes of downtime a year. And I once was talking to a bank, and we were talking about downtime. And I said, realistically, how much downtime do you guys have a year? And they say, we average between 10 and 15 minutes a year of the system being down. So that's some pretty high availability. But you can't really get in other platforms. The other thing to think about the mainframe is the mainframe account, this says here, they account for 68% of production workloads, but only 6% of IT spend. And you can see over here, the world's leading organizations, they rely on the mainframe. And, like I said, we're transaction-based. That's where the mainframe really shines. It's estimated that 55% of the world's commercial transactions run through the mainframe today. I could tell you, without dropping names, but I will. And this is probably dated information because probably the last time I talked to, I don't talk to customers about mainframe stuff anymore in my Agile role. But one time I was talking to JP Morgan Chase, and they said they averaged, probably 10 years ago, they averaged 5 billion transactions a day. That's a lot of transactions, right? As far as data serving, right? I've seen numbers that upwards of 70% of all commercial data is originated on and managed on the mainframe. The way I kind of explain to people is, do you have a bank account? Your money's sitting on a mainframe somewhere because every bank I know has their data in a CICS database. Even when you go, a story I love to tell is, when I first started the Agile thing, I would talk to mainframe customers and they say, go away, Dave, we're the mainframe. Agile's not going to touch us. We don't care about this stuff. Years later, they're all beating my board on, saying, we got to do something. I'm like, what happened? And they said, all these people out on their phones with these banking apps, they're hammering our CICS databases because they're getting like their account balances for 73 times an hour. I'm like, yeah, that's part of it, right? So yeah, it's very good at storing stuff in either CICS or DB2 or one of the mainframe databases. And it's trusted and secure computing. Like I said, the platform was built for security, and there is a thing that we're maniacal about called transaction integrity. The system's always available at the highest level of security, and it has almost limitless scale. The other thing is it's the economics and efficiency of it, right? The same energy footprint of the past four generations of System Z. So you hear me talk about numbers: the Z14, the Z15, and the current one is the Z15, 16, right? While dramatically increasing computing power, right? They haven't really updated or grown as far as their footprint, as far as how much power they consume. And if you're worried about green stuff, right? If you're really worried about climate change and green things, the mainframe is the greenest platform there is, because you get so much more computing power out of so little energy consumption. So that's what the mainframe is about, and it's still a viable platform. Although I will admit the market's shrinking, it's not shrinking very quickly. Right, so we do have customers moving off of mainframes onto other platforms for various reasons. The biggest reason is that a lot of mainframe people look like me with the gray beard, and they're starting to retire, go away. At Broadcom, we kind of address this we actually hire people out of college. So you graduate with a 4-year computer engineering degree. We bring you into Broadcom, and what we do is we grab you. We do it virtually now. We used to actually bring you to Pittsburgh for 7 weeks, and we taught you the mainframe. Because while all the cool stuff you learned in college was great, the mainframe is a completely different beast. And we teach you how to code in, dare I say, assembler language, how to, the other languages like COBOL and stuff, and how the mainframe operating system works. And then you go back to your teams and you learn the products you work on. And we've been very successful with that. And we'll talk about that a little bit when I get further into the presentation. So that's the mainframe. This is the world I've lived in for the past almost 30 years. So back in the day, and just to kind of level set, I've probably done every job there is to do in Broadcom. I was originally hired by a company called Legent in Pittsburgh because I was a Novell CNE. You guys remember what that was? That's how we used to build networks before Microsoft ate the world. It was Novell. And they needed a Novell CNE for this project they were trying to build up, and I got hired by Legent, and I never worked on a Novell server since I was hired because I kind of transitioned into the mainframe. Legent was acquired by CA, which turned into CA Technologies, which was acquired by Broadcom, and here I am. I've done level 1 tech support where I answered the phone and answered the questions. I've done development where I've written code. I've done sustaining engineering work where I chase bugs, and I've done quality work too. So I've pretty much run the gamut of stuff you can do software-wise in the mainframe is development. And this is how we used to do things back in the day. We used to work with this what they would call thing called waterfall, right? That was how we did things. And we used to do it to build and deliver our products. And here's how it kind of worked. Waterfall is kind of called a phase-gated operation, right? And here's what happens. You would start out by figuring out what the requirements were for your customers, right? And that would manifest itself in what we call a requirements document, right? And we'd take that requirements document and we'd have conversations about how we're going to design this thing, right? That would turn into what we call a design document, or what we call a DDS, or a detailed design system. We would take that document, and that's how we would implement the product. That's how we write the code, right? And then we would come out there with actual software. And notice it's called waterfall because it's kind of like water cascading down a waterfall, right? And the thing about a waterfall is you can't go back up the waterfall once you're down. And that's what's part of the problem here. Once we got that, we went into what we called verification, where we actually tested the software, and then we released the software and go into maintenance mode. What we get wrong. And this whole process would take between 12 to 18 months, sometimes as long as 3 years. So got some stuff wrong. For example, nobody saw the functionality the team was building until the end of the project. Notice, like I said, it was a phase-gated thing. Once you went through a gate, you couldn't go backwards, right? So our stakeholders and customers couldn't see what we built until we were done with it. And we only found serious problems we didn't test at the end until they were already baked into the software. So, customers learned pretty quick. If they wanted something new in the product, they had to get us when we were in the requirements phase. because we wouldn't change once we went through. And that caused us to treat our customers terribly because, think about it, you wouldn't get, if you say, hey, Dave, I wish you would put this widget into your software, and you have to wait 18 months to see if I'd even accept it. That was kind of bad. And the biggest problem was team would pick a deadline and stick to it no matter what, right? Your bonus, your raises, your promotions were all centered around, did you make your date or not, right? And because of that, stuff like QA or testing didn't get done because teams were judged by releasing on time. And somehow when you're in that situation, the non-programming tasks always seem to get cut, especially as the deadline gets closer. Even more troubling is we used to have meetings like this where, and I took part in many of these meetings where we'd sit around a table and we'd say, hey, QA person, are you sure this is a Sev 1 or Sev 2? Because we can't release the software with any Sev 1 or Sev 2 issues. And if we do, we're all going to miss our date and we're all going to be impacted severely, negatively because of it. Because basically we bullied the testers into allowing us to release the software. We put bugs in it, right? This created bug mountain, which always came back to bite us, especially if you're working on sustaining work like I used to. So that was the problem. And right around 2016, we came up with a solution, which was an Agile transformation. So this is how Agile kind of works. So you got this thing, this is what we call the Scrum machine, right? And for the lack of clarity or anything, I'm just going to go through this quickly. Hopefully you guys all know what this looks like, but I'm just going to kind of go through it. So the Scrum machine kind of looks like this. You have new roles within Scrum that were created. One is called product management. This isn't technically part of Scrum, but we kind of split it out this way. Product managers go out and they talk to the customers, and they try to find out what's going on with customers, right? And the thing that becomes painfully clear when you're a software developer is you write the software, you don't use it. I'll give you an example. One day I was working the phones as a support tech, and I get a call from a local convenience store here called Sheets. Right now, I was supporting a product called Automation Point. It was an outboard automation product. What that meant was it sat outside of the mainframe, ran on the Windows server, and it connected to the mainframe console, and it was able to automate messages off of those consoles. Simple enough, right? I get a call from Sheets, and they say, hey, Dave, Automation Point's down. I can't monitor the temperature of my coolers. I'm like, what? No, it's down. I don't know. My pop's getting hot, man. I'm like, what are you talking about? And as the product evolved, we kind of evolved Automation Point from actually looking at 3270 consoles, and we added the ability to do the RS-232 data stream, or to telnet the things and grab messages too. So it wasn't just mainframes anymore. We're connected to all kind of different hosts. I said, how are you hooking Automation Point to your coolers? And he goes, well, we were looking at some kind of software to monitor our coolers, and what we found out was our coolers had an RS-232 port on the back that was supposed to hook to a printer. So we got our soldering gun out, we wired up a cable, I hooked Automation Point to it, and every 15 minutes, the cooler thinks it's sending a temperature to a printer, but it's actually sending it to Automation Point. The moral of the story is that customers use our products in ways we never think of to solve problems we never hear of. And that's why we have a product management that goes out there and actually talks to the customers and tries to understand. And they do things like design thinking workshops and things to make sure that the customer is in line. And we're actually building things that the customer actually wants. Imagine that. The second role we have within Scrum is the product owner. Now, this kind of replaces the role of the development manager. The development manager used to tell you back in the waterfall days what you were going to code, how you were going to code it, what language you were going to use, and how you expect it to look at the end, right? Product owner does things a little differently. He actually takes these things called user stories, which are pieces of work written from the user's perspective, not from an engineering perspective. It puts us in this thing called a backlog, which is down here. And the backlog is developed during a thing called sprint planning and refinement. So what's a sprint? A sprint is this, also this guy called the Scrum Master, who's responsible for the agility of the team itself. And you also have the development team. Now, a little bit different here. When we built development teams, back in the waterfall days, you used to have the development team and the QA team, or the testers and the decoders, right? And they would always be at odds with each other, right? Because the coders were the coders were paid about how many lines of code they wrote, and the testers were paid by how many bugs they found. So you can imagine how well that worked out, right? Now they're all on the same team. And the idea behind Agile is you create a cross-functional, self-managed team that has all the skills necessary to get the job done. And the job is they work in these things called sprints. That's a 2 to 4 week window there, right? Where you build, you take things out of your backlog and you build them, those user stories. And the idea is at the end of that sprint, you have a potentially shippable product. The other thing the Scrum Master does for a team is he removes obstacles to allow the team to focus on actually writing software. So a good Scrum Master will do something like this. On a day, let's say you walk in to come to work on Monday and your laptop doesn't work, it's dead, right? A good Scrum Master will say, okay, get you a loaner laptop and get you back to writing code, delivering value. He'll take your old laptop and he'll do all that fun stuff that you never want to do, which is like open the ticket to get it fixed or send it out or do whatever's going to happen. That's the idea. The Scrum Master is there to serve the team, the servant leader to the team, and he removes obstacles and also facilitates all the fun stuff that we do here in Agile. At the end of the 2 weeks, we should be able to deliver a potential, what we call a potentially shippable product. Whoops. Just let's do one more click there. So a potentially shippable product doesn't mean that we're going to ship it to the customer. Sometimes we do, sometimes we don't. But the idea is, at the end of the 2 weeks, that thing we built is done, which means done, which is funny. Part of my job as an Agile coach is I tell people with very high collegiate, guys with advanced degrees what done means, because done means done, which means done. It doesn't mean it compiled. It doesn't mean, hey, it's done except for these few tests we have to run. It doesn't mean it's done, but we still have to write the doc. No, done means done. And that's called a vertical splice, and that's what that stuff does, right? Within these 2 to 4 weeks, we also have a daily iteration where we have what's called a daily stand-up meeting. And this is a cause of great angst in the Agile community. It doesn't mean you have an hour status meeting every day, because a status meeting works like this. Your boss is looking for a reason to jump down your throat, and you're looking for a way to cover your butt. That's not a status. That's not what we do at a daily stand-up. Daily stand-up is where the team makes commitments to each other. Where you say, hey, I'm going to work on this today. I finished this yesterday. I'm going to start working on this today. And the team can say, hey, Dave, I can help you with that. Or maybe I can start writing a test for that. Or I can start writing a doc for that. The team makes commitments to each other, and they figure out what's going on every 24 hours. And the most powerful part of the 2 most powerful pieces of Scrum are at the end of this 2 to 4 weeks, we have what we call a sprint review or demo, where we show our stakeholders and customers what we built and get feedback, right? In a perfect world, we actually give the code to the customer, let them play with it. Kind of how we're doing a mainframe. We'll talk about that in a little bit, but we get that feedback, and that feedback can drastically change what we work on next. Because I'm building software for you, not for me. So I want to build software for what you need, not what I think you need. And then we have this thing called a retrospective. The retrospective is where a team gets together and talks about what went well, what didn't go well, and what they might want to experiment with on the next sprint. It drives a actual culture of continuous improvement. There you go. All right, so that's based on, and nuts and bolts, that's what we did. So what did the Agile culture shift look like to Broadcom? Well, we built those cross-functional self-managing teams. So we actually lumped in QA and development and everything, and we staffed the roles and the other thing going, right? We had to make sure the team has the skills necessary to get the job done. That can mean programming languages too, because as we go further and further into the 21st century, stuff like Java and React and all these modern languages start to creep in, right? And how are we going to make that work with mainframe teams that are very good at things like assembler and COBOL? Working in sprints was big. And the thing that makes working in sprints big is something called a definition of done. Remember how I said you do it till you're done, and done means done? Well, that's how you define it. You have a team agreement, and you agree this is what done means as a team. And done can mean checked in, branched, all that good stuff. Tests are all run, docs, all that stuff. So the team basically says this is what we agree to be done, and the team all ratifies that, and it commits to it, and off you go, right? Testing and documentation became part of the definition of done, right? And this led to the testing shifting from an ice cream cone to a pyramid. I'll tell you what that means in a minute. We also instituted a continuous delivery validation model. So which meant that, we would deliver software once every 18 months. Now we deliver software more frequently in smaller chunks that customers can play with. More on that in a second. And we also put this thing together called a validation program. To put it in far too simplistic terms, we have customers sign non-compete agreements and come to our sprint reviews. Those demos I talked about, we have customers come in and give us feedback, and actually sometimes even touch the systems and play with the software. What's this ice cream cone thing I was talking about? Well, that's right here. The software testing ice cream cone. This is the way that we were doing testing before. And if you notice, the biggest tests, or the biggest part of the test were manual tests. People sitting in front of keyboards doing this. Then we had some automated GUI tests and some integration tests and some unit tests, but the vast majority of the tests were manual, which was not efficient and led to lower quality because we weren't running as many tests and we weren't really doing what we wanted to do with the systems, right? So this is what we kind of inverted into, the software testing pyramid, where the base of the pyramid and the biggest thing that you do is your automated unit tests. And then we added the automated component test, integration test, API test, GUI test, and the smallest part at the very top is we still have some manual session-based stuff we have to do, but it's a very small part of the testing. So we do this to maximize test coverage. You know, we want to maximize the coverage of the application's functionality. We want to scale with the business. You know, some types of testing just don't scale to automation. The goal is to create something that will keep up with the expected growth of the application under test. Makes sense, right? And we want to have bulletproof testing results, right? If a test failed, you know, it could mean your nuclear reactor's overheating, or it could just mean that somebody had a typo. If your nuclear reactor is overheating, you don't want false positives, right? So you want to understand that. And you also want to build the ultimate kind of regression testing. You know, we want to know what we break before we break it, kind of, the best we can, right? And we want to focus on integration and continuous builds, which we'll talk about when we talk about DevOps. So we kind of flipped the ice cream cone on its head and made a pyramid. That worked really well. And, you know, we kind of instituted Agile testing principles, which is early and continuous testing. Back when we were waterfall, testing didn't start written until all the code was written. In our early days of Agile, we mini waterfall things in 2-week sprints, meaning we would write the code, then you'd test. We want to test as early as possible. In fact, I say this and I get punched in the face sometimes, but we even instituted a little bit of test-driven development, not a whole lot, but a little bit, where you write the test first and then write the code to pass the test. Bottom line is we really kind of focused on automated testing and really wanted to increase our test coverage with that. This would also be a whole team approach, which means developers can write tests. But here's the thing. I really had to coach the QA people through this, and it took them a while to figure this out. But there's a difference between a testing mindset and a development mindset. And you want to try to instill that testing mindset in developers, because if you don't, developers are going to happy path the tests, which isn't really valuable, right? So the people on the teams with more of a testing background became more testing consultants than often the guy that wrote all the tests. And they helped and they empowered the dev team to really have a bigger code coverage of the tests they wrote. And we want to have frequent deliveries, right? We want, and you know, every 2 weeks is probably a bit much for the mainframe. You know, I sat down with my very first mainframe team, which is the SysView team. We're going to talk about that in a second, right? And I was this newly minute Scrum Master. I said, okay, guys, we're going to do this thing called sprints. Every 2 weeks we're going to build something and deliver it. And they go, we can't do that. I'm like, why? Well, it takes us 4 weeks to build. No, we got to fix that problem first, don't we? So that's kind of the way that works. And then we actually upgraded to this thing called the Scaled Agile framework, where the big problem we had is when we got Agile, the teams got pretty good and they were actually delivering stuff. The business didn't grow with the teams, right? So with my SysView team, we got a release done early. The next release of SysView, we got it done early. We got it done like 6 weeks early. We had to wait like 2 months to figure out where we're going to put the next release because the business wasn't ready for it to be done early. So Scaled Agile, I won't go into detail on it. Some people love this, some people hate it. It helped us in a couple ways. Number one, it helped us to align the business from top to bottom. It helped us to synchronize our cadences from top to bottom. Right now, we're not really doing safe anymore. We actually threw some of the stuff out we didn't like planning everything out in grotesque detail for a quarter, because we found that shortly after planning, everything changed. So all that planning was done for waste. But we did keep the good parts. So because I want to kind of show you that we were doing that. But even through this whole Agile thing, there were still problems. First is testing did improve dramatically, but we found that testing could become a bottleneck. Also had some hardware challenges with the mainframe. You know, you can't go to Best Buy and buy a Z16. It doesn't work that way. So there were ways to virtualize systems, but they were a headache to maintain. And there's a thing called VMware, which Broadcom is about to purchase. I find it hilarious because VM was around about 30 years before VMware was on the mainframe. But the VM system couldn't really give the teams the performance they needed to support some of their testing workloads. So that was a problem. And, you know, all of our products, okay, maybe quite a bit, but the majority of our products are written in languages like assembler, COBOL, right? not supported by modern tools like Jenkins. So we still had, and the big thing is, even with the automated testing we were doing, people still had to manually look at the test results. It was not the best use of the human. So what do? We kind of shifted to DevOps. So enter DevOps. And here's Gene Kim, who's called the father of DevOps. He wrote a book called The Phoenix Project. If you're in the DevOps, and following up the Phoenix Project, he wrote the DevOps Handbook. So if you want to go further with DevOps, I would suggest reading at least the Phoenix Project and seeing if you want to go further. But he kind of defines DevOps like this. DevOps is those set of cultural norms and technology practices that enable the fast flow of planned work from, among others, development through test and operations while preserving world-class reliability, operation, and security. DevOps is not about what you do, but what your outcomes are. All right. So how do you get to DevOps? Well, there's three main terms. There's the three C's of DevOps: continuous delivery, continuous integration, and continuous testing. At the risk of being simplistic, DevOps looks like this. You write a line of code and you check it into whatever source control you have. That triggers your DevOps pipeline, which is your set of tools and processes utilized by the team to compile, build, and deploy code. So what happens is you write that line of code, you check it in, it automatically triggers a build of your product. That's the continuous integration part of it. Why? Because, I don't know how versed you guys are in software development, but there comes a point in time where you got to do a merge, right? Because you're all working individually. You can't all work on the same source at once. You got to merge it. This kind of continuously merges things, right? So you have a continuous integration where you're building this thing, and you're going to find out pretty quick if you broke the build or not. And if you do, you get a nasty gram saying Dave broke the build, and you have to go fix it. But that's the first thing that happens. If the build is successful, it automatically deploys to your continuous testing platform. So somewhere out there, you got a system set up, and your newly freshly built code is deployed out there, and you start to run your automated test against it. So you're continuously testing what you're building, which just basically jacks your quality through the roof. I like to put it this way. I have bought 3 cars from Carvana, which to me it's amazing. You go online, you pick the car you want, and they deliver, or you deliver to it, or I can go down to Bridgeville and put the big coin in the vending machine, and my car comes down to me, right? But when I bought the car, I've never once asked if they ran a safety test on it to make sure that this car was safe and it was going to run. I kind of expect that, right? And our customers kind of expect that out of our code too. So that's how DevOps work there. So let's talk about the product that I used to be the Scrum Master for, and called SysView. All right. The name of the product is SysView Performance Intelligence, and it basically gives you a view of the system. It has very, very, very deep hook into the mainframe operating system and hardware, and basically tells you everything you ever want to know about the performance and what that system is doing. So they call it comprehensive performance management. And it basically looks at the system, the subsystems, and all that stuff. Tons of assembler code in this thing, and it's stored in another Broadcom product called the Endeavor Storage Management System. It is the industry standard for mainframe storage management. It was designed to automate the development process, and it governs software change from the very first line of code to deployment, including change tracking. So before that, the build process was manual, hand copied, very mistake prone, right? Now we use 2 Broadcom products, Endeavor and MSPS. And basically, builds are kicked off manually, but Endeavor has MSPS takes things from there. The source is copied from the dev system to a sandbox system, and from there, the rest happens, including the build and patches. And we deploy things on a mainframe with something called a PTF, which is an acronym which I can't remember what it stands for, but that's how basically, when you get your tar files and stuff, and that's what a PTF is on the mainframe. So we've got rid of the error-prone manual process, but we still had the problem of the fact that everything's still on a mainframe, and we can't use modern tools. So we kind of went from manual testing to batch regression testing. So the SysView team got together, and they actually used a part of the product called the SysView Scheduler, which is basically automation. Kicks jobs off and runs them at a specific time, right? So basically, they wrote test automation where every week, every SysView command was run and tested using the SysView Scheduler. SysView is basically a CLI. It runs off a green screen. You enter commands to get the information you want to see. So every one of those commands, we wrote automation to test it. And the commands were run by each SysView feature. Now, the funny thing about SysView, it was basically 6 mainframe products jammed together to give you this comprehensive system view. And it has things for CICS, which is a mainframe database, IMS, which is another MVS or ZOS operating system, and also I'm sorry, basically the thing. So all that stuff we exercised all that stuff. We also took SysView and we actually expanded it, so it talks to other things off platform, right? Both on the mainframe and off. So we wrote tests to test those integrations too. So we had basic other machines help us with batch regression testing. For example, we have Windows servers set up that will push CI/CD transactions through those databases for us. So that's how we did that. Now with new development, the feature tests and test automations are done as new functionality delivered by the teams. It's part of our definition of done and part of every user story we do. And then we add them to our batch regression test suite. This all worked out pretty good, but a couple of things wrong. It was a step in the right direction, but the tests were still needed to be manually checked. So somebody had to sit through and go through the results of each test and make sure they were successful. So we went to step 2, which is the new modernization journey, right? So we actually says we're going to build out a DevOps pipeline now. So this thing took about 3 years for us to build because we built a little bit at a time. As always, the automated tests were added with every new feature. So, but this also gave us more time to code and less time to test, and we had fewer, and ended up with fewer escape defects. Right? So the players here, Endeavor, we kind of talked about that. That is the source code repository for the mainframe, and there's all the assembler and COBOL code. We used a webhook server and bridge for Git. Bridge for Git is something that we developed within Broadcom itself as a bridge between Endeavor and GitHub. So basically, it syncs code, to put it bluntly, it copies the code off of the mainframe onto Git. Basically, clones it into GitHub. And then we used Jenkins to orchestrate our DevOps pipeline. Basically, preferred it due to integrations, some of the integrations it had. So the Git-based front end provides the software management capabilities and the lifecycle automation of Endeavor. So we take advantage of the software management capabilities and lifecycle automation. And then with GitHub, we create those mappings with synchronized Endeavor. And we inventory those locations with the Git server repositories. Now, the webhook itself is an HTTP-based callback function that allows lightweight event-driven communications between the two applications. Then Jenkins pulls that code into the pipeline, and we're now in the distributed world. And we use Python as the programming language, and Zoe. So Python's, you guys should be familiar with Python. It's a super popular language, right? Zoe provides interaction with the mainframe. So we can write pipeline scripts using Zoe CLI commands. So what's Zoe? It's another product we wrote. Basically, it was a consortium with the Linux Foundation and a couple other companies, one being IBM, the other one being Rocket Software, to build this thing. So Zoe's a bunch of stuff, but the thing that we found very, very advantageous for us, it provided a command line interface that allowed you to basically embed mainframe commands into a Python script. So, it's a Zoe CLI, it's a command line interface that allows you to interact with the mainframe remotely. And we could use common tools like IDEs and shell commands and bash scripts and other stuff to basically help with mainframe development. So that's what we did. And it looks kind of like this. So here's the tool chain, right? So a developer checks something into Endeavor, all right? Using the webhook server, we actually post that out and we do it for the bridge to Git. And this bridge to Git is actually run out on I think it's a Kubernetes cluster. I can't remember. But anyway, it's basically in some kind of containerized thing. That triggers Jenkins, right, which is going to actually deploy over to our test server. And then Jenkins and Zoe take over and we run our tests. Now, the cool thing is that our test results are emailed back to the developer who checked it in. So that helped us to modernize our applications, to capitalize on our investment in APIs. Because one of the things that we've done with all our mainframe products is we spent probably the last 10 years writing API hooks using usually RESTful web services into our mainframe stuff. So we capitalized on that, and we automated our workload, and we have improved once again our quality greatly. So now we're moving fast and effectively, and we're improving our resiliency, because we want to take advantage of the proven testing frameworks like Jenkins and Git to get this stuff done. So Zoe and Python run the pipeline, because we can embed those Zoe CLI commands into Python scripts. And then, of course, the pipeline does all the other cool stuff like emailing us test results and keeping track of test results and all that stuff. So we've taken a very assembler-based mainframe program, and we've used modern tools with it. So how we do it? Well, lessons learned, number one, we had leadership support. The team put time aside on all their sprints, their 2-week sprints, to do this, right? We prioritized testing and the development of a DevOps pipeline, and leadership was cool with this. We also highlighted code coverage as part of our mainframe. We have this mainframe-wide initiative called Engineering Excellence, and code coverage was one of those things. We wanted to really increase our code coverage of our tests. Those two things together kind of led to the sweet spot we wanted. Like I said, no more manual testing or inspection of test results. Everything gets emailed back to the team. The other thing that happened is IBM put out some better virtual machines to increase those performance of test systems. So what IBM did was they put Linux, or what we call bare iron, on the actual mainframe box. In those things, we have virtual machines called VDTs, which are just like the old VM systems. They run on a much better, much more powerful machines. And that will actually run those workloads we want to run. The big thing, no disruption of developers from their day-to-day work. So if you're a gray beard like me and you just want to sit at your desk and code assembler, there's nothing different. You write your code, check it in, and the pipeline takes over. So I didn't have to teach. We have a mix on the team of what I would call seasoned developers and some of the new guys who brought in as part of the ASC program. It's no surprise the new guys want to use the modern tools. These seasoned guys want to do it the way they've always done it for the last 30 years. Well, it all works out. By implementing these pipelines, everybody's happy. It's a good thing. So what did we learn? So, you can say, that's great, Dave. That's a wonderful talk you're giving, but you wrote the software to make it happen. I don't want to come by. I don't want to get Zoe and all that stuff. So here you go, right? Here's what to think about. Find a way to bridge the gap. How do you get from legacy systems to the modern tools? You have to get creative, but it can be done. And second, don't boil the ocean. Okay? Focus on an iterative and incremental process. Little bit at a time, little by little, line by line, precept by precept, you're getting closer and closer. Eventually you get there, right? The results are always worth the wait. If you try to boil the ocean, you're going to get frustrated, or it's just not, once again, someone's going to say, why are you spending all your time working on this DevOps pipeline thing? I'm not getting any value out of your team. So little by little by little. As always, make as much visible as possible. So dashboards are your friends. Something else that a lot of these things will do is you can create dashboards that show your test results, along with the emails go back to it. Also, make the work you're doing as visible as possible. One of the things I always coach my teams on is, to me, Agile is simple. Make all your work visible and prioritize that work. And then do what makes sense. Don't do stuff because Agile said to. Oh, I love it when I say that. Why are you doing that? Because Agile says so. Well, who's this Agile guy? Why are you listening to him? Do what makes sense, right? The first line of the Agile manifesto is, we are uncovering better ways. They should have stopped it right there. Better ways, right? That culture of continuous improvement. So I don't care what Agile says. I don't care what DevOps says. Everybody's different. Every team is different. Do what makes sense, okay? And this is probably I tell this to everybody, and I think it works. Agile and DevOps are not rigid. It's meant to be adaptive. It's like the game of chess, right? Once you know how the pieces move, like the knight does that funny L thing, and the bishop can go, at an angle, and the rook can only go horizontally and vertically, and the queen does whatever she does. Once you understand how the pieces move, how you play the game is totally up to you, right? Back when I was in 6th grade, a long time ago, we had a 6th grade. Our room had a chess tournament, and I was going to win that chess tournament, right? So I memorized 5 moves that should be able to beat anybody, right? And it worked for the first 2 matches I had. The third match, I actually played someone who knew what they were doing, and I got my butt kicked because they knew how to play chess, and they understood and they reacted, right? everything is so, how you play the game is totally up to you. It's the same way with Agile and DevOps. Do what makes sense. So how are we doing here at Broadcom? Well, with the 3 C's of DevOps, continuous delivery. We have a continuous delivery program in place available to customers. So far in this year, we still have 2 months to go. This view has put out 81 continuous delivery releases. 12 of those are new feature PTFs. We put new functionality out for the customers to play with. Okay? 68 of those are defects that we fixed. And one of those is the level set. So the way we do continuous delivery is we put out these new feature PTFs and we kind of stack those on top of each other. Once we get to the point where we feel it's time for a new release, we put a new release PTF out, level sets everything, and we start over again. The reason we do that is because remember how I said that most mainframe systems can afford like 5 minutes of downtime a year? We expect you to put the new feature PTFs on your sandbox system to play with. And hey, that's cool. Then eventually when we verify, you can move it out to the production system. That's how we kind of do things. Continuous integration, things are set up to trigger the DevOps pipeline automatically. We're definitely moving in this direction, but we're not there yet, but we're getting there. And continuous testing. We're not actually running things continuously yet. That being said, test run as a result of pipelines quite a bit. And we just bought a new Z16. It was put in last weekend. And what I'm hoping is with that new hardware and once again, the better ZVDT stuff, we can actually set up a continuous testing platform. That's kind of where we're at. To me, SysView is the shining star. They've done this wonderfully. Other products in Broadcom are also moving in that way. The other ones that we have here in Pittsburgh, which will be Netmaster and OpsMBS, they both have DevOps pipeline in place as well. They're differing. Every product's different, so a little different every place, but we are definitely moving into the place where all our products will soon have DevOps pipelines.